Hello again. So today we're going to talk about the interworking we have done with the Bell and with the help of Cisco. So last year when I presented this, I was told the whole survey become really popular. People really like it. So I was about asked to give some update because in the last year what we conclude was within the SRv6 demand there's like 60% want compressed and versus 42% want uncompressed. But over a period of a year, when we have talked to multiple customers and when we get the request, we see a significant shift on one of the requirements. And that significant shift, like now 80% of the customer is asking about the compressed. And why not? Because the benefit of compressed is like you don't have to have SRh if you have like network slicing within 6 hop. One of the IP destination address can accommodate 6 uSID, which is really good enough. On top of if you introduce reduced mode versus non-reduced mode, and if you have reduced mode, you don't need an SRH at all. So it's just like an IPv6 from point to point. I think this is the reason, one of the popular reason people are deploying SRv6 are going from compressed. And one can wonder why 20% is still on the uncompressed. Mostly, when we talk to the customer, there are like existing customer SRv6 which already have deployed early adopter of SRv6, which has deployed the uncompressed. They want to continue like this way. And when I ask what is the reason you want to continue like this way, they says we are satisfied with it. If you want to go to network slicing, our next option is to go to flex algo first, and maybe the compressed later on. So this is what we have seen, and as a Ciena, when we offer them, we try to support both at the same time, and that gives a migration plan from non-compressed to the compressed. Other part of the option, this is part of the SRv6 in the customer. If you have listened to my earlier talk in the morning, I go in really detail what's happening. But what is key to use case is that SRv6 is becoming popular in every place, like mobile network operator, wireline, and wireless backhaul, or wireline customer. This is on the rise. And within these most asked, as I mentioned, the compressed set is the most popular option. If we go to the SIP level, as I mentioned about it, like compressed is more option. But when we go and talk about the traffic engineering part, the SR policy and flex algo is also one of the popular option. And when we talk about the protection scheme, customer really want all of them flavor. Some customer have one preference versus other, but the combination of playing together is highly important aspect for them. Some want TLFA, some want end-to-end seamless BFD for the SR policy for protection. Some want to combine both TLFA and SR policy at the same time. Some customer really using any cast SID to avoid BGP-LU and SRMPLS parts, so they can have an easy migration plan to SRv6. So there is a lot of variety which we can see the configuration and the existence of the current technology going forward. Another interesting point was the coexistence of the existing transport, RCPT, MPLS-TP, LDP. Now, in some places, we have seen the existence of SRMPLS and SRv6. But when we look in this whole topology and whole architecture diagram or the requirement from the customer, one thing really stood out: the importance of testing in-house with the service provider or the customer in-house. And this is the reason when we talked to Dan about it, the idea was very clear. We need to test a specific customer requirement in-house, and it's not like one-time activity. We need to phase it out from phase 0 to phase 1 to phase next option to really understand what is the requirement, what is the unique requirement for per customer. And when we talked to Dan, and thanks to Cisco, Clarence, and INEC from the Cisco, we came together as a team and we start working in this lab where we have full support. If we have some issues, we have a technical staff from the Ciena, technical staff from the Cisco, working together to solve the issue so we can better serve as the Bell Canada. So that was the main requirement. And what happened is, like, over a period of time, we have defined a milestone, what we need to do, what service we need to enable at what time. And going forward, we need to want to continue this kind of activities so we can adopt more futuristic technology. Like Satoru just mentioned about SRv6 MUP, it comes with the discussion with the Bell all the time. So we are going to co-host this kind of incubation technology at Bell to co-develop this feature and see if there is any limitation, any improvement, and how can we work together. So that's kind of another requirement. Another thing is the server function chaining that we are going to work, and I know Bell is interested in server function chaining. So over a period of time, we can work together on the similar fashion as well. This is my last slide. I think from the Sienna perspective, we have all the hardware from the 1 gig to all the way to 400 gig interface, from 360 gig switch fabric to all the way to 192 terabyte, all SRv6 ready. So if you have any, if you want to discuss any product with us, we are happy to discuss it. At this point, I'm going to hand over to Dan. Yeah.
So good morning, Paris. I'm going to be talking about the interop that we did with Sienna as a co-development partner. Just to recap, to start with what I presented last year on the why uSID at BAL, which is about scalability. Now, those numbers were very theoretical to test the theoretical limit. Obviously, it can go very far with 240 million SID. But if the operator has, let's say, a 30,000 node network, what you see below the 256 block, you only need one block, obviously. But with SRv6, we're also changing the paradigm of normal MPS network where you have PE and P, so you will need more label as you push towards the source. So with the SRv6, we can go all the way to the top of rack or the cell-side router, which keep the network very simple in the middle. And it allows also to do service programming and things like Dan was talking earlier in the cloud, where the numbers of labels or the numbers of SIDs become a little bit more important. So that is so important for us that we decided to do some partnership and co-development to rise up a little bit the ecosystem amongst the vendor. By no means, BAL, we intend to replace NTC, by the way. But we did a few tests in our lab. The description here was really the goal was to try with L3 VPN or DT4. In here, we're describing a vendor will have an SRv6 PE talking with another vendor SRv6 PE using uSID in the middle. We had some restriction where we wanted to see the local SID to start at E, hexadecimal E and F. This is where you have your service inside the SRv6 or inside the box, local to the box. Another restriction at BAL, we wanted to go ULE. We wanted to make sure this was followed or respected. At the same time, we are big fans of link local to make the network very simple to provision. Success of the test, we know when we can have an L2 VPN with routes that exchange from one PE to another PE from different vendors using uSID, and we can ping and trace out inside the VRF. So this is just to give you a visual of what I've just described. What you see here is the Sienna Platform 5166 R2 acting as a PE with the Cisco device 57B1, keeping an eye there too, to exchange route and then ping inside the VRF. Observe also the uSID 202 match the node ID. You just skip the 200, so 202 for R2 and 207 for R7. Keep that in mind as I move the slides. Below also you see the local SID or the service, in this case is E002. That's because we wanted to exchange IPv4 route to start with through uSID. This is a typical lab setup that we have at BAL to do these type of interop. Now we are able to ping the locator, as you can see, with the iOS from Sienna. As I move forward, we can ping also the SID or the VPN ID, E007. This part is the trace route to do, like I call it, explicit trace route, which has two uses, very important. First, we wanted to have like a tool to validate that uSID is actually working. So you could see now the uSID at the bottoms that we're forcing the traffic to do to a specific path. The other use of that is for operation. Like your support team needs to have a tool to see is uSID somewhere in the network when it's deployed is actually working, and when or where is it not working, at what node specifically. So the trace route here is to validate that you can go to a series of uSID node. from R2 to R7. But also another use of that is to validate every links in your network working. So as an example, if R5 and R6 were both ABR, I feel the sound is coming. And then that link between the R5 and R6 is just not used. And we'd like to use it when you have a failure, like your TLFA will be using these links between R5 and R6. With the explicit trace route, you can always validate if that is actually working. Here is an example of TLFA that was demonstrated too. Using uSID, you can observe the PQ nodes and what we need to see from an SRv6 uSID perspective. You can see the link locals next up address that was respected. This is another way to do it with the ping with the segment list. This one too. And now the takeaway, what we've been able to demonstrate is the interoperability between Sienna and Cisco on uSID to reinforce the ecosystem. We've been able to achieve what we wanted to see, the L3 VPN with V4 and V6, DT4. And we were able also to observe the TLFA mechanism in place with uSID. That would be it.
Thank you very much.
Thank you.
Thank you.